Welcome guys to today's class. In today's video, we want to discuss another important topic in physics, and that is equilibrium of forces. If this is the first time of coming across our video, please don't forget to click the plus sign, follow us on TikTok, follow us on YouTube. On YouTube, follow us with the handle Chydonns Daniel, and also follow us on the Chydonns Academy class on YouTube. So these two handles are our channels on YouTube. Please support our channel by following us on TikTok and on YouTube. We have a lot to learn in these two platforms. Okay, now when you hear equilibrium of forces, equilibrium, these two or more things are in equilibrium. Yes, when you hear equilibrium of forces, this equilibrium of forces, we have demonstrated them in many ways, both in practical physics and otherwise. Yes. What comes to your mind when you hear equilibrium of forces? Two or more forces are said to be in equilibrium if the total resultant force of it is equal to 0, or if the resultant torque of it, that is what we call torque. Torque means force times distance. So if the total torque of it is equal to 0, and if the total or resultant force of it is equal to 0, so three or more forces are said to be in equilibrium if the resultant torque is equal to 0, or if the resultant force acting on it is equal to 0. Yes. Now, this topic, equilibrium of forces, you will see it in moment of forces. You also see it in couple of forces, couple. You see it in couple, you see it in moment, so to speak. Okay, and so we just want to see how to solve these questions we have, so to speak. Yes, as we want to solve these questions, question number 1 says a body of mass 20 kg is suspended in air by means of an inextensible string attached by the ceiling. What do they mean by that? Look at a ceiling. We'll use it to represent our ceiling, and the body is what? Attached to this ceiling, so to speak. And look at the body now. We say it's 20 kilogram. So to Newton, 20 times acceleration due to gravity, which is constant to be 10. 20 times 10 is what? 200 Newton. That is the weight of the body. This is the mass of the body, and 200 Newton becomes the weight, because we use acceleration due to gravity as 10. Then they said another cord B is attached to the body and pulled horizontally. Remember, they said that this is inextensible string. That means you can't stretch it again. It is a type of string that you cannot stretch again. That's what we mean by inextensible. It cannot be stretched again. So when a force here is what? Dragging it this side. Another B is attached to the body and pulled horizontally on the cord A, makes an angle of 30 degrees with the vertical. So when a force F is dragging it horizontally, what it means is that when you have this vertical string you are seeing here will no longer be vertical, because when it's dragged, it will now move to something like this. So it will no longer be vertical again. It will now be what? Bent, because something is dragging it. And this is the body. Then look at the force, so to speak. Now they said until the cord A makes an angle of 30 degrees with the vertical. So it's making an angle of 30. Look at the cord making an angle of what? 30 degrees with the vertical. Okay, remember that every weight of a body acts towards the ground, or is directed towards or is acting downwards. And so weight of this body is going to be acting what? Downward. So it should be directed to down. So that means here is 200 Newton, and this is the force. Direction of the force moves this way, and this is where the tension comes. because the tension is on that string or on that chord, so to speak. Now, we now say that calculate the tension T. To find this tension T, this T, another question can say find the tension, find the force F. To find this tension T, let's see how to get it. To find it, you use a theorem called Lami's theorem. Lami's theorem, if you want to get it as fast as possible. How do you use Lami's theorem? Here is 30 degrees. You carve out what? The 30 degrees here. We said that here is also 30, and the totality of here is 90. This vertical and horizontally, so 90. 30 plus 90 will give a totality of here to be 120 degrees. Then here is 30. If here is 30 and this is alternates to this 30, giving you 32, the implication is that what? Here should be what? 60 what? Degrees. So 30 plus 60 gives you 90. Here is already 90, horizontal and vertical 90. 90 plus 60 will give you total of this to be what? 150. So 90 plus 60 is 150. And here is what? 90. Now watch this diagram well. Watch it well as I put it here. This is your tension. Then this is your horizontal. This is your 120. And this is your what? Vertical. Acting downward. So we have here to be 90, and we have here to be 150, and we have here to be force. We have here to be 200 Newton. Lami's theorem says that if you want to use it, this tension you are seeing here, look at it. This tension you are seeing here should be all over what? The angle, sine of the angle opposite it, all over sine 90 is equals to this force you are seeing here should be all over what? Sine of what? 150. Then you also say again that it is equal to this weight you are seeing, this all over this one. Weight is 200 all over what? Sine 120. So with this is what we call Lami's what? Theorem. With this, you can get your tension and you can get your force. Let's get our tension. I'll compare this tension and this one. Therefore, when you have T over sine 90 equals to 200 over this, the implication that T will be equals to sine 90 times 200 all over sine 120. T equals to sine 90 times 200 all over sine 120. You use your calculator to sort it out. Sine 90 times 200 divided by sine 120. That is 230.94. 230.94. This becomes the answer. That is about your T. If you want to get the F, the force F, this F, you say F will be equal to sine 50 times 200 all over sine 120. Sine 150 times 200 divided by what? Sine 120. That means 115.47. So F will be equal to 115.47 Newton. And T will be equal to what? T will be equal to 230.94 Newton. So T is equal to 230.94, whereas your F is 115.47 Newton. But you see, they gave you all those options here, but they are looking for tension. You say that tension is 230.95, so to speak. Okay?